Hello students, welcome to section 14. This section will be practicing the new questions about linear equations in two variables. As we learned before, now our x and y, the unknown variables, are in the denominator and they clearly form an equation that has a power of degree 2. So we have to replace 1 by x with some new unknown variable in order to solve these type of equations. Now here I have a new question. I have 6 by x plus 2 by y is equals to 1. 4 by x plus 3 by y is equals to 4. So I start off with replacing 1 by x as a and 1 by y as b. As I've said in previous classes, it does not matter what alphabet you use, all that matters is that your procedure is correct. So solving this further, I get 6a plus 2b is equals to 1. This is my equation number 1, and I have 4a plus 3b is equals to 4. This is my equation number 2. Now I'm going to use a different method in this particular scenario to solve the equations. In the previous section, we used Cramer's rule to solve the two equations. In this section, we'll be using elimination method. So by elimination method, my first equation is 6a plus 2b is equals to 1. And my second equation is 4a plus 3b is equals to 4. Now I need to make sure that the coefficients are same. So I'm going to multiply equation number 1 by 3. This will give me 18a plus 6b is equals to 3, and I'll be multiplying equation number 2 by 2. That will give me 8a plus 6b is equals to 8. So I'm trying to eliminate b. Now I have my new equations. This will be called as equation number 3. This will be called as equation number 4. I'm subtracting 4 from 3. So I have 3 minus 4 here. In terms of words, if somebody has any doubt, you'll write it in this way. Subtracting 4 from 3. Now here I have 18a plus 6b is equals to 3 minus 8a plus 6b is equals to 8. Now we have a minus sign out of the bracket, so we need to make sure that everything inside changes its sign. So minus plus here is minus, minus plus again becomes minus, minus plus becomes minus. So 18a minus 8a becomes 10a, 6b minus 6b is 0, and 3 minus 8 is minus 5. So I have 10a is equals to minus 5, which implies a is equals to minus 5 by 10, and therefore a is equals to minus 1 by 2. So my a value is minus 1 by 2. Once I get a is equals to minus 1 by 2, I need to substitute this in my equation number 1, 2, 3 or 4. Any of the equations you substitute the value of a, you will get the value of b. So I'll be substituting a in equation number 1. This gives me 6 into minus 1 by 2 plus 2b is equals to 1. So 6 into 1 by 2, 2 and 6 cancels out. I am left with 3. So I have here 3 into minus 1 plus 2b is equals to 1. Now 3 into minus 1 is minus 3. So I have minus 3 plus 2b is equals to 1, which implies 2b is equals to 1 plus 4, and therefore sorry, 1 plus 3 1 plus 3, which implies 2b is equals to 4, and therefore I get the value for b as 2. Now I have my value for b as positive 2. Now remember, we replaced a and b with, sorry, 1 by x is equals to a and 1 by y is equals to b, so I need to replace them back as 1 by x and 1 by y. So now a is equals to 1 by x and b is equals to 1 by y, which implies the value of a was minus 1 by 2, which is equals to 1 by x, and the value of b is 2, which is equals to 1 by y. So minus 1 by 2 is equals to 1 by x implies x is equals to minus 2, and 2 is equals to 1 by y implies y is equals to 1 by 2. So my solution for this equation becomes x comma y is equals to minus 2 comma 1 by 2. Now this question needs to be solved in your classwork copies because this is an out of textbook question. Make sure you practice this on your own once you have seen how to solve this. Try not to copy. If you solve this on your own, it will be for more of your practice, and it will be easier to solve future problems. Now, in our next question, we are going to take a new problem that is again from the textbook so that you all can verify the solution. In this case, we have page number 18 from the textbook. So I have page 18, example number 2. My question is 4 divided by x minus y. Now remember, x minus y is not two different terms. X minus y is one complete denominator term just under 4. So my 4 here is one bracket divided by x minus y. Now this is plus 1 divided by x plus y. This is another bracket. So x plus y is again one complete denominator for the second term, and that is equals to 3. This is my equation number 1. My equation number 2 is 2 divided by x minus y and minus 3 divided by x plus y, which is equals to 5. Now, just as we solved in the previous question, or questions I should say, we have to replace, instead of 1 by x, here I have 1 divided by x minus y. So what I'll try to do is, now I'm going to replace 1 upon x minus y as m, and I'll replace 1 divided by x plus y is equals to n. What will this do is, this will give me a linear equation in two variables for each of the equations. So let's try to replace them. Here I have 4 into 1 upon x minus y plus 1 upon x plus y is equals to 3. So this can be written down as 4m plus n is equals to 3. This is my equation number 1. Now similarly, I can write for the second equation. So my second equation is 2 into 1 divided by x minus y minus 3 into 1 divided by x plus y, which is equals to 5. Now 1 upon x minus y is m, 1 upon x plus y is n. So I'll be replacing them. So I have 2m minus 3n is equals to 5. This is my equation number 4. Pardon me, this is my equation number 2. Now once I have both these equations, all I have to do is eliminate one of them. My equation number 1 was 4m plus n is equals to 3. So I'll be multiplying equation number 1. I'll be multiplying equation number 1 with 3. That gives me 12m plus 3n is equals to 9, which I'll call as equation number 3, and I'll add 3 and 2. 3 and 2. This gives me 12m plus 3n is equals to 9 plus 4m plus 2n, plus 2n minus 3n is equals to 5. Now 12 plus 2 is 14m. This value here is m, plus 0 is equals to 14. Now this implies 14m is equals to 14, which gives me m is equals to 1. So once I receive m is equals to 1, all I have to do is highlight this so that I do not make any mistake. M is equals to 1. Now I'll be substituting m is equals to 1 in any of the 3 equations. So in this case, I'll be substituting m is equals to 1 in equation number 2. So substituting m is equals to 1 in 2. My equation number 2 was 2m minus 3n is equals to 5. So I have 2 into 1 minus 3 into n is equals to 5, which implies 3 minus 3n is equals to 5 minus 2, which implies minus 3n is equals to plus 3. Now 3 cancels out, and I'm left with minus n is equals to 1, which can also be written as n is equals to minus 1. Now once I get this, I need to make sure that I replace n and m with the values of x and y that I used in the first case. So going back to our original question, 1 upon x minus y was equals to m. So here I need to write 1 upon x minus y is equals to m, and 1 upon x plus y is equals to n. Now therefore I have 1 upon x minus y is equals to, my value for m was 1, so this is equals to 1, and 1 upon x plus y is equals to minus 1. Therefore, interchanging the values, I get x minus y. This is one complete integer. This x minus y is one complete integer. Therefore, it moves to the other side as one complete integer. So here I'll have x plus y is equals to 1 divided by minus 1, which implies x minus y is equals to 1 and x plus y is equals to minus 1. So here I have two new equations in terms of x and y. Once I solve these equations, this is equation number 4, this is equation number 5. All I have to do is add 4 and 5. This will give me x minus y is equals to minus 1 and x plus y is equals to, x minus y is plus 1 and x plus y is minus 1. This has to be added. So x plus x is 2x, minus y plus y is 0, plus 1 plus minus 1 is 0. So my value for 2x is equals to 0, which implies x is equals to 0. Once I get this, I have to substitute x is equals to 0 in either 4 or 5. I cannot substitute x is equals to 0 in 1, 2 and 3 because 1, 2 and 3 had the values m and n. That would be much more tedious to do. So I'll just substitute x is equals to 0 in equation number 4. This gives me 0 minus y is equals to 1, which implies y is equals to minus 1. Therefore, my final solution comes as x comma y is equals to 0 comma minus 1. All of you can check the solutions from the textbook. I hope this method was easy to understand. If not, once again you can talk to me on the WhatsApp group and we'll help you solve all your problems. Thank you. This section ends now.